Bandwidth for changelog is provided by Fastly. Learn more at fastly.com, and we're hosted on Linode servers. Head to linode.com/changelog.
I'm Ivan Porto Carrero, and this is Go Time.
It's Go Time, a weekly podcast where we discuss interesting topics around the Go programming language, the community, and everything in between. If you currently write Go or aspire to, this is the show for you. Welcome back, everybody, to another episode of Go Time. Today's episode is number 60, and your hosts for today are myself, Eric St. Martin, and Brian Kettleson.
Hello.
And Carlicia Pinto.
Hey there.
And our special guest for today is probably best known for his Go Swagger implementation. Please welcome Ivan Porto Carrero.
Hi.
Hi.
And Ivan, do you want to give maybe a kind of a brief history about yourself, kind of who you are, what you do, just for the listeners to kind of familiarize themselves with you?
Okay. I'm an engineer. I've been working in cloud-related in the cloud-related field for the past 15 years or something. I currently work for VMware, where I am the tech lead on a product called PKS, which is a hosted version of Kubernetes on VMware infrastructure. In the past, I've worked on machine learning systems, and I've programmed in several different languages. But currently, I use Go as my main tool for programming.
Yeah, so I saw that somebody had mentioned that you had written kind of like a Sinatra implementation in Scala, and that would mean that you probably were familiar with Ruby as well.
Yeah. So a long time ago, I was on .NET. I did C#. That's how I got started, I guess. And then I got dissatisfied with the lack of open source within Microsoft, but they did Iron Ruby, and that's how I got into Ruby more or less by contributing and talking about the Microsoft's Ruby on .NET system. So I helped build or I helped work on Iron Ruby at the time.
Did you work with Jeff Lamb?
No, Jeff, a little bit. It was more with the people. I forget the names because I'm getting old, and it's been a long time. I worked with Shri Borde. Jeff Lamb was involved in the early days of this. So this was really around the DLR and this whole Iron Python and or the dynamic language runtime for the CL for .NET basically. But Shri Borde was the team lead at the time, and then there was a Jim DeVille involved and a few more people. So I worked on Iron Ruby or with Iron Ruby by writing a book for Manning, which never got published because Microsoft canceled the project before the book was finished. Or at the same time that the book was finished, really. And so then from there, I also started a startup at that point where I was going to do real-time social media filtering. You can look at it today, would probably be the most similar to IFT, because you could set up some query parameters, and if a Twitter feed or a Facebook feed or whatever social media feed would raise an event that matches those query parameters, it would trigger yet another webhook or some other event that you could then react to. To do so, I had to analyze the Twitter fire hose and so on, and Ruby didn't get me far enough, so I started looking for something else, and I found Scala. Scala at that time only had Lyft as a web framework, and Lyft, people said it was very interesting, but from my point of view, it was a web framework that conflated all kinds of responsibilities. And so I started looking for something that looked like Sinatra, because Sinatra was as concise as I could think of for developing web apps. or APIs. And so there was a proof of concept at the time, which had just been renamed to Scalatra. And so I started contributing. And after a while, I was one of the main contributors on that open source project. It was fairly successful, but Scala itself has problems. The language is good. The community is very divided. And if you work with it on a team, it's not very conducive for, in my opinion, to have people with very different backgrounds come together and get up to speed very quickly. And so I started looking at Go to find out, or I wanted to know if Go would actually deliver on that promise, so that you can have a team, you can get your team to expand fairly quickly, and people shouldn't have to have like weeks of ramp-up time just to learn how to leverage the language to their advantage. And so far, it's been delivering. And so that got me here. In meantime, through Scalatra, I got into Swagger because we have to document APIs. The company that invented Swagger, they hired me, and so that's how I got deeper and deeper into that entire Swagger and Open API story. And when I switched to Go, there was nothing there. And so I figured people in Go also write lots of APIs, so they should have a way to document them and use them so that other people can generate clients for it in whatever language. And so that's how I got to writing Go Swagger.
So let's like back up just a second too, and let's give a little bit of a rundown on what Swagger is for anybody who may not have used it or familiar with it.
So Swagger is currently known as Open API, I guess, but it started its name as Swagger. The reason it was named Swagger because the only alternative he had was something that is the acronym of WADL. So in the office, people would go, "Why WADL if you can Swagger?" And that's how the name came to be. So from there, everybody who writes an API ends up having the same problems, right? So now you have a bunch of clients who are talking to your API. You still want to be able to evolve your API over time. You bring new people on board. They don't know how to use your API. They don't know what the inputs are, what the outputs are, especially if you're writing a dynamic language kind of API. So to formalize those expectations between the boundaries that existed within our teams, we came up, and many people like us have come up with a format to describe what goes into the API. So essentially, it's just a schema for your input and output parameters that captures what some people look at as a contract for your API. Once you have a machine-readable version of something like that, you can take it in many different forms. So the very first thing that we then did was make a UI for it. Because now you have this API. If you run the UI, you point it to this description, which is hosted with your API. You can show nice documentation, especially if you add some Markdown or some richer form of documentation, and that documentation lives with your code. So that's important, so that for every version of your code, you actually have a complete form of documentation for the API that application exposes. From there, obviously, machine readable makes it also that it's easy to generate clients for your API because you now know exactly what goes in and out of the API, so you can generate a client for it. If you then take that a little bit further and you make the API specification easy to define, from there, you could also look at it, now, why don't I do a contract first and I start generating a server? And here Go is particularly strong because it allows for these broken up definitions in many files and so on. And so I took this from what we've tried with Scala, take an API specification and just generate servers for it that implement the entire specification. So you don't have to really think about all of the ceremony, but just start writing about start writing the things you care about, the things that happen after all of the common code. And so that's a rundown of what Swagger is. Of course, there are marketplaces now where you can look at all of the APIs other companies expose. And so the bigger dream here is if every API exposes a Swagger spec, then you never have to download a client SDK anymore. You can just always generate one.
Yeah, one of my favorite things too is like whenever you use a new API for something, you're always kind of poking around at it and trying things out. And the fact that you can just go into the Swagger UI and kind of play with the example requests and submit them and see how they return and things like that is extremely valuable. Kind of it's wasteful to spend a lot of time building these little example things just to poke at the API.
Yeah.
So, Ivan, describe in a bit more detail how do you go from the Go codes to having the beautiful HTML API documentation, and what do you need? Do you need to boot up a server to serve that HTML? How does it work?
Okay, so yeah, so what you need is you download the binary, a Swagger binary, and you add some vocabulary in your document comments. So the way, because there are two main use cases here, right? So generating a specification from an existing code base, which I suspect, but I really have no way of tracking that. I suspect most people use something like Gin or whatever, and they just want to get a Swagger JSON file come out. In that case, what I've tried to do is define a number of documentation comments that also look good when you just do GoDoc to describe what is in your API. So you document your routes with some of the expectations that are required for Swagger. You document your models, and you just write doc comments, basically. And then you run Swagger generate spec, and you point it to your main package, and it will reflect over your application and generate a Swagger JSON file. From there, you take the Swagger binary and you do Swagger serve, and point it to the spec document that you just created, and it will serve up an HTML UI for you.
So if I want to have a system where I can share this documentation with my entire team, should I have them download what's the best way? That's what I'm trying to think. Should they download the binary and run? And for example, I can have the Swagger documentation file on GitHub somewhere, maybe together with my project. They download that, they run it themselves, or should I put up a server to run so like we can all access online?
So you don't have to download the server necessarily, as long as you publish the Swagger JSON somewhere.
Not a server, the binary, the Swagger binary, right? The tool.
Yeah, you don't. Once you have a Swagger JSON document, you don't really need the binary anymore, because there is.
Because it's generated already.
Yeah, you have the Swagger JSON. So if you push the Swagger JSON onto like a gist or something, then people could use the raw URL and use it with pitstore swagger.io to leverage the UI that is published there and just paste that in the address box there, and then it will serve you the UI there.
If I have it on a GitHub repo, would I get the nice interaction?
No, you need to have your API running. Yeah, you need to have your API running. So the best way to do it is what was originally specified, or part of the specification was it would always be at the root/Swagger JSON, and so of your API. So if you run your server, you have to make sure that it serves the Swagger spec somewhere together with your API, so that the host and the base path and so on are all filled in correctly, so that any client who can look at it knows how to use your API because it has the URL where you can find it, and at the same time it has all of the documentation or all of the expectations filled out.
Gotcha. Thank you.
If you use the Swagger binary to generate your server from a Swagger spec you define up front, then you get all of that for free, because it's part of the server that gets generated.
Mm-hmm.
There are several Go routers or multiplexers that have varying forms of support for the Swagger spec. So some of them, like Go RESTful, will automatically generate the Swagger bits. And some of them require you to do things like doc comments to generate Swagger. And then in the other direction, there's Goa, which uses its own DSL and then generates Swagger from that. So there's lots of good support in Go now for Swagger, but Go Swagger was definitely the original and certainly the first one I ever used. I definitely appreciate that it existed. I've been using it for years.
Cool.
Yeah, and it actually exists in more projects than people probably realize. Like I'm fairly certain both Docker and Kubernetes have Swagger support.
Yeah, both. Actually, the Docker API, last I looked, but things might have changed again, uses the generated version of it. So they use it to generate their models. And then Kubernetes uses it through Go RESTful. But then custom resources in Kubernetes, it's custom resources now, right? They use the toolkit that I built for validation of those resources, for example, because within the toolkit lies buried also a fully typed implementation of JSON schema and the JSON schema validation and so on. So that is as part of the Swagger implementation, I had to develop this. There were varying libraries to do JSON schema within Go, but most of them had some problems, and I tried to submit some PRs. They never got accepted, so I decided to fork and just make it work the way I wanted it to work. And so, yeah, it's in many places. And last week there was a project, Meka.io or something. I can post it later on in the Slack channel. That generates a whole series of tests for your API. So it will then try to fuzz test your API when you generate it based on the Swagger spec.
Oh, that's nice.
Yeah, I agree.
So now you're at VMware working on the PKS team?
Yeah.
I think it's kind of amusing that half of the tech industry is employed now in some way, shape, or form around Kubernetes.
Yeah, well, when I joined VMware, I started making noise about Kubernetes. And after several false starts, we landed on doing this PKS thing. Kubernetes has been this interesting evolution, right? It's like, let's do OpenStack, but not OpenStack. Let's make it a lot better, make it all around containers. I do think it solves a problem that most people have at the moment. So it's been a very interesting process to see that grow up, that project.
Yeah, it's really, really exploded. And I think that it was a really awesome initiative to begin with. But like a common conversation I have with people like with adoption of Kubernetes is just maintenance of the infrastructure in itself is work. So like people will be quick to implement it, but then they find like they're struggling with having to maintain Kubernetes and all the little failure scenarios and things like that, and not their business logic. And then they end up with a team that just supports Kubernetes, and that's why like all these amazing product offerings for managed Kubernetes, PKS, and Microsoft's new AKS and GKE. Wait, what's
GCE, GKE?
GKE, yeah. Yeah.
So yeah, I mean that's kind of like the perfect world, right? You get all the benefits of Kubernetes. You only have to focus on like developing apps that are kind of cloud native and run on it, and you don't have to worry about the infrastructure.
Yeah, well, at VMware, it's a fairly interesting mix here because by definition, people are worrying about the infrastructure because we have this vSphere product. So the people we go to typically know how to deal with hardware and all of the failure scenarios that come from there. I do think that it's this interesting thing. So Kubernetes allows you to package your app and and deploy the containers and do all of that service discovery, all of the cloud native stuff you actually require to run these larger infrastructures. But I think most people are surprised by how much Linux you have to know to really operate it well, because it doesn't hide anything from you. It's there. It makes extremely creative use of the kernel facilities, and so it's a very technically it's a very interesting project to me.
Yeah, it's a lot of fun. And I think that there should be experts in that stuff too. Like, don't get me wrong, but like a lot of businesses, especially smaller businesses, they're worried about, having to scale fast and things like that.
Yeah.
And then, once you start hitting odd scenarios and stuff like that, and you hit saturation points and things fail in odd ways, and then your team who was developing features now becomes firefighters trying to figure out some of the issues and things like that. So yeah, and I mean, it's a fun world, right? Like, some of us enjoy doing that, but not everybody has the extra resources to be able to do that. And like you said, like with the on-prem people and stuff like that that are used to running vSphere and things like that, like they've already got that expertise on their team. And not every team is fortunate enough to have the kind of infrastructure expertise.
Yeah, I'm very interested to see what's going to happen with Istio, because that's a very puzzling project to me. Like, I understand the problem it's trying to solve, but I think most businesses who look at these solutions are latency sensitive, and I don't know how Istio is going to solve that particular problem. Because at the moment, when we run our simulations, it adds so many hops that it becomes a weird proposition. I really want to see the service meshes take off, because in the end, the distributed system problems are being solved there with the circuit breakers and all of these calling patterns that they encapsulate. But it's going to take some work still. So that's the thing I've been looking into lately.
Yeah, there's a lot of interesting things that have popped up in maybe the last 6 to 9 months. You've got Istio, Envoy, that came out of Lyft. Like, that's super interesting. And all of these are so early, and they work and they solve problems. But I'm really interested to see like what the version 2s and 3s of those look like. Because like you said, you kind of add additional hops and virtual interfaces and all these things, which on top of adding latency also add more points of failure and weird debugging.
Yeah, that's I think one of the unsolved problems so far. It is just, how can we tell you what's broken right now, and how do you get out of it?
Yeah. I think one of the hardest parts right now is everything's moving so fast and there's so many cool projects popping up, is kind of like that analysis paralysis. Like, which one of these will be the thing, right? Like, you could adopt Istio and in 6 months nobody's using Istio. There's some new thing, right? And everything's just moving at the speed of light in the kind of container and orchestration world right now, that it gets really hard to settle in and just commit to something. Because especially if you're a large infrastructure, right? Like, if you pick Envoy or Istio or something today, swapping that out later could be a huge effort.
Yeah, and you probably already have solutions in place, right? So most of these companies probably already have like a library like GoKit in their infrastructure that allows you to encapsulate all of those calling patterns, like call all the services at once, drop all the requests unless when I have the first response, and so on. And that's essentially what's being captured there.
Yeah.
So anyway, so it's going to be interesting to see it play out. I'm going to be a spectator in this one because this this whole Go Swagger thing keeps you fairly busy. So in between my work.
Is that what you work on most of the time?
Actually, I used to. So I used to work on it most of the time. I wrote it originally just to prove a point. But then it became fairly useful, and VMware started adopting it as well. So now I have somebody else working on it who is steadily fixing bugs. So I got corporate sponsorship finally. And I am personally much more interested in distributed, decentralized distributed databases. So having another unsolved problem that exists, but I don't know how many people are actually confronted with it, is gossip doesn't work well. I'm sure you're familiar with Serve or Console at the very least from HashiCorp.
Oh yeah, definitely.
Yeah, or Cassandra, for example. And so all of these systems, Akka is another one from the JVM. All these systems are gossip-based membership systems, and they exhibit very interesting failure behavior. When you turn off, like if you have a deployment of 100 or 1,000 nodes and you turn off 50% or 60% of the nodes, things aren't going to go well. Cassandra gets to data loss. Console takes a long time to stabilize. Akka similarly. And so with what we've been working on, or what I've been spending my free time on with the VMware research group, is improving the gossip algorithm. And so I'm working on that actually in my GitHub account. And so the results we have is we go from interesting failure conditions to ideal case. And so I want to prove that out a little bit more, and then hopefully submit some talks next year.
That's funny, because I was creeping on your GitHub account today, and I found that Go Rapid repository, and it looks like that's what you're doing there, is decentralized computing.
Yeah, that's exactly it. We submitted a paper to ACM SIGCOMM earlier this year. It got rejected because we forgot to compare against Zookeeper. Obviously, we were all like, who uses Zookeeper these days? But
anybody with a Kafka cluster.
Yeah, it depends on what circle.
Does Cassandra still require a Zookeeper cluster?
No, Cassandra has their own gossip protocol.
Okay.
But Kafka does Zookeeper. Then Mesos, I believe, uses Zookeeper as well. There are a few people who choose Zookeeper. I think they go by, it works really well, but I would say for some definition of well, that works really well. If you have a small cluster, it might be okay, but like the operational cost and overhead of it is just not worth it. Anyway, so now we submitted our paper again. Once it's accepted, I can publish it because it's a double-blind paper, so I can't just publish it before it gets accepted by some conference.
So tell us how PKS works. PKS is an implementation of Kubernetes for distribution on VMware. So does it provision Kubernetes on VMware systems?
Yes, but it does more than that. So it is a joint effort between Pivotal and VMware, and to some extent also Google for the Cloud Foundry stuff on Google. Now, this doesn't mean that PKS requires Cloud Foundry. It can be used next to it, and it can be used standalone. So what I work on from at the VMware side, at least, is the integrations with the VMware stack, then the optimizations we can do at the hypervisor level to work with something like Kubernetes, so that you get these benefits of maintenance mode and the separation between your hardware and your actual workloads. And it uses BOSH, so that's the only required. That's the one component that's required, is the BOSH piece. BOSH, if you're not familiar with it, is a lifecycle manager for applications. And so it's something that will monitor your application or your infrastructure. If something goes wrong, it's going to take immediate action. So if one of the nodes becomes unresponsive, for example, or some failure condition happens, it's going to try to restart the processes. If the processes aren't to blame, it's going to recreate the VM. So that's, in a nutshell, what it does. So it's a managed unattended version of Kubernetes. Earlier, somebody mentioned that operating these things is annoying. This is exactly the type of intelligence we're trying to encapsulate in that project. So that it takes away the operational hard headaches of it. It will also do like zero downtime upgrades and so on over time. I think that's in a nutshell what PKS is. And other than that, we make sure that it can leverage just all of this stuff that VMware already has, right? Like a log insight for log aggregation and Wavefront for metrics aggregation and so forth. I'm employed by VMware after all.
Well, that makes sense. So on the networking side, does it use VMware's networks for Kubernetes overlays?
Oh, yes, sorry. Yes, it does NSXT. So it includes NSXT, which is VMware's overlay network. It's the second generation of it. And what this does over any of the other solutions that are out there, because most people will typically go with Flannel originally and then maybe look at something like Calico for the policies. It actually gives every pod a container interface that can be managed outside of just the environment. So you can have a network administrator who sets up a bunch of global policies in some other system, the NSX management plane, and that will then translate into rules for Kubernetes, for example. There's more stuff to it, right? Because NSXT is quite an extensive piece of work. So it's pretty optimized in how it deals with sending traffic and doing the routing rules and so on, but those are implementation details of NSXT itself. What is unique, I think, is that it has a centralized management plane for all types of container interfaces. And that is where Kubernetes also takes advantage of it. So NSXT has, or the NSX team has an integration for Kubernetes that it also works with some of the other Kubernetes distributions. And so, yes, it's a very important piece of it, the security aspects that NSXT brings to bear.
Now, if I remember right, there's a lot of components that have been built by either Pivotal or VMware that kind of contribute to this system. I know there was something called Kubo. That's related to this, right?
Yeah. So Kubo is the Kubernetes on BOSH. So that is the piece that interacts with BOSH, which the BOSH works through a system called releases. A release is some archive that has some metadata, in addition to having all of the source code, potentially all of the source code to rebuild that particular release from scratch. And it then has also all of the monitoring and failure conditions that it knows about and their remediation. So encapsulates all of that in a single package. And that is what Kubo is. Kubo is open source and everybody can use it. It's not very involved, but it does require some work to get that set up in your environment. And then PKS is the piece that will make it easy to set that up in your environment with the UI and so all of the management tools that you would expect for an enterprise environment. So hooking it into Active Directory and setting up RBAC and all of that kind of stuff, all of those controls that you expect from an enterprise application is what goes into PKS, which is closed source.
Nice.
And so so far it's been working fairly well. We hope to release this by December, or somewhere in December. I'll put it that way. I can't say exactly when, because it's an agile process. So it's more like around this time, something will get released.
Awesome. So I think we are probably like 2/3-ish away through the show. Do you guys want to jump into some projects and news? And Ivan, feel free to jump in too and mention stuff or comment on things that we bring up.
Okay.
So who wants to kick this off with stuff they've kind of ran into this week?
I'll start it off. I think there's an exciting new project called Factory from Mike Perham, who is probably most popular for the Sidekick project that most Rails apps use for background tasks. Factory seems to be pretty much a Sidekick successor, but written in Go, and it supports Go and Ruby natively. It looks pretty slick. and it feels like maybe it's the thing that happened after you learn from building Sidekick. So I'm excited to play with Factory, and I'm more excited because Mike has done a really good job of something that most open source companies can't do, which is make a living off of a single open source project. So he's got Sidekick and Sidekick Pro, and I'm pretty sure he's paying the bills with just Sidekick Pro. So I hope that he can continue to evolve that model, because that's really slick.
It's going to be interesting to watch if he's going to change what's behind his service from Ruby to Go.
Mm-hmm.
This is great, by the way, great finds. Yeah, I've used Sidekick a lot in the past.
Yeah, same thing. Back in my Ruby days, I used Sidekick a lot.
And you can do your own code for this, but it has a nice dashboard and so easy to use.
So last episode, we told everybody to update to Go 191 and Go 184, I think it was. So there is a minor patch release, 192 and 185, which has just some basic updates to the compiler and runtime and stuff. But if you are noticing issues with Go Get on non-Git repositories, those will fix it. That bug was introduced in the last batch release. Other updates, GoBot released 1.7.0, which has OpenCV3 support in it. So now we can do all kinds of vision stuff with our hardware projects. And they introduced, I'm trying to remember the names of them, but from the GopherCon Hack Day, a couple people implemented support for some other drones and robots and stuff.
Oh, nice. Yeah, Ron is a machine.
Do you know that Ron is going to GopherCon Brazil?
Oh, really?
That's awesome.
Yeah, that's awesome.
Pretty sure he is. He's scheduled to speak about GoBot and IoT.
I love Ron. He's just so passionate and full of energy.
Yeah.
Just an amazing guy.
Yeah, I'm definitely gonna find a way to have dinner with him when we are there. Nice.
So I came across another interesting project called Authhouse, and this is at github.com/imqs/AUTHAUS. And I haven't played with it yet, but it looks like it might be the beginning or maybe the evolution of something that could be a really solid user authentication system for Go. Back in my Ruby days, we had Device and all of those other Ruby things that really did auth well. And there's really nothing that's kind of shown on the Go side in terms of authentication and authorization. So I'm really hoping that something will come out that isn't OAuth. We need an easy way to add authentication to our Go apps. So I'm excited to play with this one at some point when I have some free time, and hopefully it's as good as it looks.
Then let us know how it goes. I'm feeling so proud of Go right now. I feel like it grew from a teenager into like a young adult. It's maturing.
And now, do you know how that's going to compare to some of the modules for Authboss? Because I know they had like a password authentication, and they've got like email confirmation and things like that.
So the last time I looked at Authboss, and I don't know if this still applies, but the last time I looked, there were a lot of broken things in Authboss, and they didn't really seem to want to fix them. They wanted to do a rewrite and kind of fix the overall architecture. So I don't know if Authboss has been rewritten. There were a lot of things it didn't support when I looked at it a year or so ago. So I don't know if I can answer that question very well. In its 1.0 version, Authboss was not all that I wanted it to be.
Yeah, and that's the thing with most open source projects. Like you see them and you're like, I want this thing, but it's not production ready, right? Like we're all guilty of it. It's like, oh, it's on GitHub. I can totally use it in production.
Well, it doesn't bother me to jump in and help them make it production ready. I just like the idea that somebody has taken a vision and started to see it through to reality. That's usually when I find the projects too, is somewhere in between vision and reality.
So our next one, I am particularly excited about. Who wants to talk about GRV?
Oh, wow. GRV is awesome. Have you pulled it down yet?
Yeah, I have.
Oh my God. It's awesome.
Have you seen GRV, Ivan?
No, I'm looking at it right now, though. Looks cool. I wonder
Yes.
how it compares to TIG, because I've used TIG in the past a couple of times.
Which tool?
TIG. It's similar in goals. It's also a CLI, a terminal version of a Git client.
I haven't seen that one. But yeah, this it looks really awesome, and it's probably going to solve a lot of the use cases where I try to pull up GitHub for stuff. So I'm actually really excited about trying to use it more. Anything that keeps me in my terminal makes me happy.
This looks really good.
So we should probably explain what this is. I don't think anybody has mentioned that. So this is actually a command line UI for Git, and allows you to kind of see like all the remote branches and the branches that are there and tags visually and kind of like a column. You can kind of jump through the commits and see the diffs and all that good stuff just from like console UI, and it's actually ridiculously cool. And with it just starting out like this, I'm excited to see what gets added later.
It's got a great UI, and I think it's going to be a pretty useful tool in my toolbox. The installation isn't the most fun in terms of Go apps. It does require CMake because you've got to build libgit 2. So when you go get GRV, there's actually a make file that you've got to run. And so it works wonderfully on Mac and Linux. I'm going to bet that it doesn't work so great on Windows.
But this is really cool. I use an actual GUI tool to see diffs because it's the quickest for me. But you can't do search on those tools. And I see that you can do queries. It seems like it has not only you can do queries, it seems that it has a lot of flexibility. So that is really cool. I only know how to query one thing. It's like git dash capital S logs. It's the only thing I can remember.
I'm going to drop a screenshot into our Slack. I just ran GRV on the GRV repository, which is kind of meta, but that's okay. And I'll drop a screenshot in our Slack because it's so cute. It reminds me a lot of what's the mail program, the Unix mail program, like Mutt or.
Oh, right, yeah.
Very similar to that in terms of look and feel.
Okay, so what else we have? DEP 0.3.2 was also released, and that added kind of import support for GVT and GB, and it had some other kind of bug fixes and improvements. So if you are currently using DEP or were waiting for something that would auto import from GVT or GB, I encourage you to play with that.
That's been one of the one of the best blog posts I've ever read about version management from the guy from.
Yeah, Shane
from
Boyer.
Sam Boyer.
Or Sam Boyer, yeah. I don't know why I said Shane.
What is the name of the blog post?
So you think you want to write a version management system? Something like that.
Yeah, that was very well thought through and very well explained.
Yeah.
Yeah, it definitely gives you an appreciation for the people who have to solve these dependency management problems.
Yeah, because it's always your problem is always the easy one to solve, right? It's all the other ones.
So the last thing I have in the news and projects is the latest issue of Just for Funk from Francesc. Campoy is amazing, amazing, amazing. It's got the Go tracer in it, and he walks you through how to use it from start to finish, and it's awesome. I love the Go tracer so much, but it's severely lacking in documentation. Severely lacking.
Tell us what the Go tracer does. I actually looked to see if that was explained anywhere, and it really isn't.
It isn't. Go tracer allows you to instrument your Go applications and capture performance metrics that you can then put through these different tracing tools. Go tracer is one of them. And it lets you see, for example, what you're spending most of your CPU time on, or where you're allocating the most memory. The better tools are visual, and you can click on things and find out, because the graph is bigger, this is where I'm spending more of my time, and you can drill in and get all the way down to the function level. All right, this code takes more time than anything else, or I'm calling this one function so many times that it's taking all of my CPU time. So you can drill into your app and find performance issues that way.
Cool.
So it's a good video.
Oh,
go watch that.
I do have one, and I'm gonna get the link now, but I forgot to put it on the doc. It's Bill Kennedy came out with a blog post explaining channels, and if you use the channels but you don't understand them really completely, or if you don't use them because you don't understand how they work, if you read this blog post, I promise you will. It might take you a while to digest everything, but he explains it really well. He gives really good contrasts, and he speaks in a very simple language. So I thought it was a really great public service for him to do that post. And I happen to know it took him a month to put it together. It's really well done.
Oh, wow. Yeah, I saw it come out. I haven't had the chance to read it yet. I'm trying to convince myself I have time to code right now. Okay, so are we ready to move into Free Software Friday?
Let's do it.
So, Ivan, I don't know whether you listen to the show, but basically what we do every week is we give a shout out to an OSS maintainer, group, or project, just to kind of show the love. It does not have to be written in Go. So anything is up in the air. We often give shout outs to like tools and things like that we use.
Okay. I haven't given it much thought though. So
and yeah, you don't have to have anything.
Yeah, it's just fine. I'll start. I wanted to shout out to Francesc because the work that he does for the Go community and the effort that he puts into his podcast and his blog posts and his tooling and his documentation, incredible. Very few people work that hard. So Francesc Campoy, we love you. Thank you so much for all of the things that you do for the Go community.
Yeah, that whole series, like everything he does is amazing.
Oh my God, I couldn't agree more.
One of my favorite things he did was that Go tooling repository. That's just so awesome. It's like a README with all of the awesome Go tools.
Let's have a link on the notes for sure.
I'm looking.
I don't know if I've run into that. Don't remember.
Carlicia, did you have anybody you wanted to shout out to while he pulls up the link?
Well, besides seconding what Brian just said about Francesc Campoy, I'm going to take that lead and say the same about Bill Kennedy, William Kennedy, but we call him Bill. just, I was so inspired by the post he just did about channels, which, by the way, is called The Behavior of Channels. He just, just by doing blog posts and his tweets and little big things that he does all the time.
And he travels a lot and does kind of free workshops and things like that.
Yeah. He's a big support of the community.
He's always giving.
Mm-hmm.
So mine for this week is Go Num. And if you haven't seen it, it is filled with libraries for like linear algebra, statistics, probability, things like that. And I'm really excited to see how this progresses. It is a world I'm not as smart in. So I'm glad people are writing these algorithms for me. But I'm mostly excited about it because Python with the NumPy library seems really to be the area that people are working in some of the more scientific regions. So seeing these things introduced in Go makes me hopeful that we'll start seeing more of those projects being completed in Go as well.
That would be awesome.
Go is growing. And look at this documentation. I love it. Pretty awesome. Really well put together.
So, do we have any other shout outs we want to do? If not, we can wrap this thing up and we will play around with some of the people in the Slack for our after show.
Let's tie a bow on it.
All right. So, definitely thank you everybody for being on the show. Huge thank you to Ivan for taking time out of your busy schedule to come and join us and talk about all things Swagger.
Thank you, Ivan.
Thanks for having me.
And a huge thank you to all of our listeners. Definitely share the show with friends, coworkers, all that good stuff. You can follow us on Twitter at GoTimeFM. If you have questions for the guests or hosts, or you want to make recommendations for guests or topics, please file an issue at github.com/GoTimeFM/ping. And with that, goodbye, everybody. We'll see you next week.
I'd just like to point out before we go off the air that the holiday season is coming. It's now, we're recording this at the end of October. You'll be listening in November. So remember that Go Time is the best gift that you can give your friends and your family for the holidays. So just keep that in mind as the holidays come close.
Steal their phone, subscribe to the podcast on their behalf, and tell them you're welcome.
Nothing says love like giving the gift of Go Time. Goodbye, everybody.
All right, that's it for this episode of Go Time. Tune in live on Thursdays at 3 p.m. U.S. Eastern at changelog.com/live. Join the community and Slack with us in real time during the shows. Head to changelog.com/community. Follow us on Twitter. We're at GoTimeFM. Special thanks to Fastly, our bandwidth partner. Head to fastly.com to learn more. Also, Linode. We host everything we do on Linode servers. Head to linode.com/changelog. GoTime is edited by Jonathan Youngblood, and the theme music for GoTime is produced by the mysterious Breakmaster Cylinder. We'll see you again next week. Thanks for listening.